everybody and welcome to this episode of Data Vectors. This is the fourth part, and we'll be continuing from where we stopped in the last episode. This part we are going to be doing is scalar product of two vectors, that is the dot product, and also the vector product for two vectors, that's the cross product. We are going to be dealing with the angle between two vectors. So let's get into this. Now, for scalar product of two vectors, you'll be given two vectors A and B. So when you are asked to look for the scalar product, you also use the dot product, and that will be A dot B. The scalar product will be represented as A dot B. So let's see. Using two vectors A and B. So let's say scalar vector. Scalar vectors of those A and B. Scalar product of that is A dot B. That is when they are without the unit vectors. But when the unit vectors are involved, we'll be having right. But in case of unit vectors involved. So maybe in this case now we are having our A in the form of I, J and K. In that we have A1I plus A2J plus A3K. We also have B in the form of B1I plus B2J plus B3K. You can see now that it's in form of unit vectors. So what do we do in this case? We look for the dot product. So what is dot product? It's as if you are multiplying. So you bring them, replace them with the dot in the middle, and you pick the related unit vectors. That is the I for I and J for J. So by that we are having A dot B. Let's place them now. We are having A1I plus A2J plus A3K, then dot, we are having B1I plus B2J plus B3K. So now, now they are final answer. You just by picking this related ones, we are having, no, before we do that, let me chip in something. Now, you notice that if you multiply this together now, we have A1, B1, then I dot I. Now, if you are having I dot I, or J dot J or K dot K, it will lead to 0 because they are on the same phase. For example, now if you are having I, maybe it's on X direction. If both are on X direction, there is no angle between them, so it will be 0. The angle will be 0, and the angle is 0. For example, now you are having I dot I, and you are looking for the scalar product. Maybe for example now 1 multiplied by 1, then you have so this should be cos, not sine. Sine is your vector product. Sorry about that. So we are having cos 0 as it starts. So and if you have cos 0 is 1, so you have 1. So when you are multiplying this together, it will be 1, then you have only A1 and B1 left. So that's for that. So final answer that we have A dot B, multiply them, we are having A1 B1 plus A2 B2 plus A3 B2. That's that. Please note that cos is for scalar product and sine will be for the cross product, for the vector product. So calculate for scalar product, it is A dot B equals to AB plus theta. That is when you are given the angle. But when it is involving the vectors, note that these words are going to use. You are going to use the dot product. Then you multiply the related unit vectors together. So now for the vector product, so now moving to the vectors product of two vectors. Now the same process. We are given two vectors A and B. Now you already know that I said this is the cross product, and what do is to represent that is cross multiplied by. So we are having the vector product will be A plus B. And what would that give us? That would be AB. This time around it is sine. A sine theta. So now that's when the unit vectors is not involved. But when it is involving the unit vectors, what do we do? Let's make it out. So in case of unit vectors, when we have our A, just like the other time, A1I plus A2J plus A3K, and we also have A as B1I plus B2J plus B3K. So now, what do we do here? We look for the cross, and this will lead us to determinants. It will lead us to determinants. So when we are dealing with under vector products, when we are dealing with the vector products of two vectors, and you notice that we are using cross products for unit vectors, it's going to be determinants. So we are having A cross B. We have a determinant. So we take out each unit vectors up. We are having I, J, and K. So you pick the one for unit vectors for I. The component under I, they are A1 and B1. So you can write A1, B1. The component under J, they are what? A2 and B2. You write A2 and B2. Then the components under K, they are A3 and B3. So if we now solve it the way we solve our determinants, let's take equation on that. Let's take equation on that. We take equation on scalar product and also take equation on vector product. So for example now, let's say we are having, let's say we are having our A as 2I plus 3J plus 5K, and we are having B as 4I plus J plus 6K. So how do we find the scalar product? It's in form of unit vector already. So just say A dot B, then it will be the dots. So that will be 2I plus 3J plus 5K dot 4I plus J and plus 6K. So you now start to pick the related unit vectors. Here we have 2 and 4. So 2 multiplied by 4 here. 2 multiplied by 4 here will be 8. Now notice that I is multiplying I is the I dot I will give you 0, like I said the other time, because it's it will give you one other. So if you multiply 1 by 8, it will still remain that. So you don't need to include the I anymore. So that's why it is called scalar. Scalar doesn't have direction. So plus 3 dots I dot 1 I J here. You have A, then plus 5 and multiply by 6. That's you have 30. Let's check that. So our answer will be 41. So that means A dot B is what? 41. So that's the scalar product. Now for this one, let's take question 2. So here we have example 2. This is example 1. It said if E equals 2I plus 4J plus 3K and Q equals I plus 5G minus 2K. Okay, now we have to find the cross product. Find cross product. Okay, now and what's cross product? Cross product is A cross B. As simple as that. So we already know that we are using the determinant method. That is here. So we're bringing out, since we know our P and Q, now we are using P and Q instead of A and B here. So you just see P plus Q, then you draw out your determinant The first thing you do is to indicate your unit vectors. That's I, J, and K. And remember, when you are dealing with determinants, you always note the sign. That's plus, minus, plus. So for I, what are the components under I? We have 2 and 1. So 2, 1. Then under J, we have 4 and 5. That's 4, 5. Then for K, we have 3 and minus 2. 3 and minus 2. So now we can, bring out the determinant and solve them accordingly. So get into that. Yes, we are still on the line. So now we can be having I, determinant of. So we are crossing out whatever you have on the row and column of this place. So we left with this. So that's 4, 5 and minus 2. So minus 3. Yeah, this one is cancelled out, this one is cancelled out. So we are left with this 4. We have 2, 1, 3 and minus 2. Then plus K. And what's K there? It's cancelled out, this cancelled out. We are left with this. So we have 2, 4, 1, 5. So, and you know the law for determinants, you multiply this minus the multiplication of this. Multiplication of this minus multiplication of this, that's the unit. So let's do that here. So from here now, we're having I into brackets. If you look at this place now, you see that 4 multiplied by 2 minus 2. That will give us minus 8. And we have minus 5 multiplied by 3, which is 15. Minus 8 minus 15 for this place. I. Then let's do for this. 2 times minus 2 is what? Minus 4 and minus 3 times 1 is 3 here. Then for this, we have K into brackets. 2 multiplied by 5, that's 10, minus 4 multiplied by 1, that's 4. So now we can bring them out. So minus 8 minus 15 will give us minus 23. So we have I as minus 23. Then we have minus 8. Minus 4 minus 3 will give us minus 7. Minus 7 multiplied by minus J. That will be plus 7J. Plus 7J. And lastly, we have K into brackets. You can write it normally. See, there isn't P and Q. We have P multiplied by Q. Should be minus 3I plus 7Q. And this is the vector product. The two vectors. Now moving on to the last part of this section, we have angle between two vectors. Now, when we are dealing with angle between two vectors, we will be using directional cosines of the two vectors. So when we are given vector A, we get directional cosines, and we go to that directional cosines are gotten by L, M, and E. So given two vectors, let me just write the short note of that. Given two vectors A and B. Their directional cosines are used So now, what do I mean? For example, now we can have, let's say the directional cosine for A now. The directional cosine of A. Let me see for A now. I have L, M, and M. And it's directional cosine for A. Then for B, I have L prime, M prime, and N prime. Just to differentiate them from each other. So now when we are asked to do for the angle between vectors, we have cos theta equals to the multiplication of each of them, the sum. So we are having cos theta is equals to nn prime plus mn prime plus nn prime. Now, the normal formula is n plus m plus n for each of them. So, but now that we are using the two of them in check, we are given two vectors, so we have to combine them together. So we end up with this, and know that we are looking for the angle to make angle separate of the formula. So that would be angle is equals to cos inverse of nm prime plus mn prime plus nn prime. So now we can use that to further get our nose, which is the angle. So let's look at an example on that, and we round up for this episode. So we have find angle between two vectors as example 3. Find angle between two vectors P is 2I plus 3J plus 4K, and Q is 4I minus 3J plus 2K. So what do we do? You find the magnitude of, there's now you are going to look for directional cosine. If you remember what we did in the last video, you are going to look for the magnitude first. So when you look for the magnitude, you now express the formula of Lm and M respectively. So now look for the magnitude of 2, which is also written as this. And you also look for the magnitude of Q, which is also often written as this. So now, magnitude of Q will be, looking at P, we have 2, 3, and 4. So that will be 2 squared plus 3 squared plus 4 squared. And that will be 4 plus 9 plus 16. This should give us a root of 29. So same thing here, same thing applies here too. For Q we have 4 minus 3 and 2. So 4 squared plus minus 3 squared plus 2 squared. So now 4 squared 16 plus 9 plus 4. Still the same values here, so we still have our root of 29. Now to get NN for this side, so we have NNN. Remember, what's the formula for N? It's going to be the A over the magnitude that we got. And what's our A? Our A is 2. So we have 2 over 29. 2 over 29. Root 29 rather. Then for M we'll be having 3 over 29. Then for N we'll be having 4 over 29. So as you can see, the next one will be N prime plus N prime plus N prime. So the same thing also. For N here we'll be having 4 over root 29, then minus 3 over root 29. Then here we'll be having 2 for N prime, we'll be having 2 over root 29. So now that we've gotten our L prime, N prime and N prime, we can now use the formula that we derived the other time. So as such, let's manage this for this. So the something that we'll be having for theta is equals to cos inverse. So we now bring in our L is 2 root 29, 2 over root 29, then multiplied by this 4 over root 29, then plus the M and M prime, which is 3 over root 29, 3 over root 29, multiplied by minus 3 over root 29, then plus the n and m prime 4 over root 29 multiplied by 2 over root 29. So we can go further on that. Let's begin. We are having the angle so 2 multiplied by 4, that would be 8 over when root is multiplying root, it will mean that number. So we'll be having 29 here. So 29 plus 3 times minus 3, that's minus 9. So that minus will affect this place. So plus times minus is minus. So we'll be having minus 9 over 29. Then 4 times 2 is 8 again. We have plus 8 over 29. So now if we do the LCM of this, we are having theta is equals to cos inverse, and they are looking for the LCM of this. So it will be this divided by this one multiplied by 8, that's 8, then minus 9 plus 8, that's the LCM. So if we do this, we'll be having 7. So that's cos inverse of 7 over 29. So what would that give us? Approximately that should be 76. That should be 76. Thank you. Do not to like, share, subscribe and comment. Wait for the next one. We are not done yet. Thank you very much.